Hello, we are studying crystallography, and in that, let us understand the concept of symmetry. Now, beauty is many a times associated with symmetry, and we say nature loves symmetry, whether it is with respect to time or whether it is respect to space. So, there are several symmetrical natural objects, for example, snowflakes, or even some of the flowers where the arrangement of petals is symmetric. Now, when do we say an object has symmetry? Well, there is an inherent congruence when you say symmetry. So, there could be some operations which can map it into congruence with itself. Now, there are symmetry operations and symmetry elements. So, what is the difference between the two? So, if a symmetry operation is carried out, you can say it's kind of a movement of a body such that when the movement has been carried out, every point of the body is coincident with an equivalent point. Or you can say that, suppose if you note the position and orientation of a body, close your eyes, and when you open your eyes, even though the symmetry operation has been performed, you don't notice any change. So, basically, a symmetry operation leaves the final state of the body indistinguishable from its original state. It goes to an equivalent state. Now, there are different ways. There is a simplest of all is identity operation, or there's reflection, there's inversion, or even rotation, proper rotation and improper rotation. So, proper rotation is just rotation, and if there is a reflection involved after rotation, it's improper rotation. So, all these operations, even though they have taken place, it is going to get back the object to its original position. For example, think of a square. Square we know is more symmetric as compared to rectangle. Square has all the sides equal, rectangle has only opposite sides equal. So even though the angles are 90 degrees in both the cases, just by visualization you can tell that square is symmetric. Now consider an operation such as rotation. If you rotate the square either by 90 degree or by 180 degree or by 270 degree or even 360 degree, it is going to remain a square itself. Or if I have to be more specific, if I rotate it by 90 degree and if I do it 4 times, then I get back the original square. So you can say it's a four-fold kind of a rotation. So that's an example of a symmetry operation. Now, what is a symmetry element? If you think of rotation, there has to be some axis of rotation around which or with respect to which the rotation is taking place. So, axis of rotation is kind of a geometric entity. So, such geometric entities with respect to which one or more symmetry operations are taking place, carried out, are basically symmetry elements. Now, there can be different types. There can be points, there can be lines, there can be planes. For line, we already saw an example of rotation axis. For point, you can think of the point as center of inversion. Also, when you think of reflection, there has to be a reflection plane with respect to which this happens. So, that plane is also an example of symmetry element. So, symmetry operations are carried on an object or a body with respect to symmetry elements.